All right, today we're going to talk about complex numbers and trigonometric notation. So the first thing we want to kind of talk about is how do I graph a complex number? So if I have my graph, let's say I have 2 plus 3i, and I want to graph that. So what we want to do is create a Cartesian coordinate plane here so where we can graph this. Well, the a becomes my x, the y is my imaginary piece. So this is my bi, and this is my a. And so I would go over 2, up 3, and that would be my graph of 2 plus 3i. So if I had negative 1 minus 4i, okay, I'd go negative 1, so I'd go left negative 1, down 4, so this is negative 1 minus 4i. Okay. So now we're going to talk about what happens if I have the absolute value. If I have the absolute value of a complex number, that's a plus bi. So the absolute value of a plus bi, what that's going to be is that's going to be the square root of a squared plus b squared. So if I have the absolute value of 3 plus 5i, what I'm going to do is come in here and I'm going to square 3, I'm going to square 5, and I'm going to add them together. So that gives me 9 plus 25, which equals the square root of 34. So what we're really finding here is we're really finding the hypotenuse of that piece here. So if I was to graph this, here's our item here. So this is 5, this is 3, and I'm really using Pythagorean's theorem to find that this is the square root of 34. So that's the absolute value. You're going to need to know the absolute value because what we're trying to do is we're going to come in and finding the trig notation for complex numbers. So we're actually going to use trig functions here to find our a and b. So here we have that a, remember our complex number is a plus bi. So a is equal to r cosine theta because in our graph, a was our x, and x is equal to r cosine theta. B was our y, so b is equal to r sine of theta. And so here, if we put it together, we have r on the outside times the quantity cosine theta plus I sine theta. And so, or I could have that r be pulled in, so I have r cosine theta plus ri sine theta. So what we're going to do is we're going to look at how do I find those pieces out. Okay? So if I want to find the trig notation of 1 plus I, we'll do this. What we're going to do is we're going to kind of graph this to get that idea of where it's at. Okay? So there's 1 plus I. So I now have this triangle where this is 1, this is 1. Okay? So I need to find my r first. Okay? So I need to find the absolute value of 1 plus I, which is going to be 1 squared plus 1 squared, which is the square root of 2. Okay? So now I know r equals the square root of 2. But how do I find my theta? So my theta is going to be, remember, I have an x and a y here. And so what I'm going to do is I'm going to take tangent inverse of y over x. So this becomes tangent inverse of 1 over 1. Okay? Which gives me, if I was in degrees, this would be 45. If I was in radians, it would be pi fourths. So now my trigonometric notation here is going to be the square root of 2 cosine of 45 degrees plus I square roots of 2 sine of 45 degrees. All right. So we'll do one more of these where we will use the radian measurements. All right. So let's go ahead and erase this real quick. And let's find one more. So let's go the square root of 3 minus I. All right. So So the first thing I want to do is I want to find r. So r is the square root of 3 squared plus minus 1 squared. Okay. Square root of 3 squared is 3. So 3 plus 1, which gives me square root of 4, which is 2. So now I know my radius there is 2. Okay. So I'm going to find theta. So here's my x, here's my y. So this becomes tangent inverse of -1 over root 3. So hopefully you have your radian conversion chart with you. Okay. I do not, so I'm going to have to plug that in. Okay. So tangent inverse 1 divided by, and that gave me negative 30 degrees, which is the equivalent of negative pi 6, which is 11 pi 6. There's one other instance for that. You can find that in there. If we are in quadrant 4, so we have this 11 pi 6 because we have a positive x and a negative y, so we're in quadrant 4. So we now have 2 cosine of 11 pi 6 plus 2I sine of 11 pi 6. And hopefully you understand that we are in quadrant 4 because we have a positive square root of 3 and a negative 1. Okay. All right. So we're in quadrant 4, and then the 11 pi 6 is in quadrant 4. So now we're going to find the standard form given that we are in trigonometric notation. So what we're really going to do is we're going to find cosine of 120, sine of 120, and then multiply it by 2. So this becomes 2 cosine of 120 plus 2I sine of 120. Okay. So what that does is now we're going to multiply through. We're actually going to plug that in to cosine of 120. I know that's on your radian conversion chart. That should be a lot faster. So this gives me -1 to sine of 120. And this is, okay, so plus the square root of 3I. And there's my piece there. If you use your calculator, this is going to come out as a decimal. So make sure you look at your radian conversion chart on these. Okay. So the next thing we're going to talk about is multiplying. What happens if I multiply a complex number, and what happens if I divide? And so we have multiplication. So if I have R1 cosine of theta 1 plus I sine of theta 1 times R2 cosine of theta 2 plus I sine of theta 2. Okay, that's a terrible cosine. Okay. I want to have a nice, easy product here. I don't want to have to FOIL these out like we did in our regular one. And so what happens here, this becomes R1 times R2 cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So when we have the product of complex numbers, what we're going to do is we're going to multiply our separate radiuses together. And then what we're going to do is we're going to add our angles here for each component. Okay, so on division, we're going to have another nice formula. And then we'll look at a couple of examples of each of these. So let's say I have R1 cosine theta 1 plus I sine of theta 1 over R2 cosine of theta 2 plus I sine of theta 2. Okay? So we're going to have something kind of similar, what you kind of expect. So we're going to have R1 over R2. We have a division here. But now what we're going to do is we're going to have the difference of the angles. So I have theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. Right? So that's going to give me my formulas there to find the product and the division of complex numbers. Right? So let's look at 3 cosine of 40 degrees plus I sine of 40 degrees times 4 cosine of 20 degrees plus I sine of 20 degrees. Okay? So now we have our product there of our complex numbers here. So what we're going to do is we're going to come back over here. We're going to come back to our formula. So this is equal to 3 times 4. And now I'm going to have the addition of these. This becomes cosine of 40 plus 20 plus I sine of 40 plus 20. Okay? So this becomes 12 cosine of 60 plus I sine of 60. And there's our product. Now, if I wanted to convert it into a true standard form of the complex, I would have cosine of 60, I'd have sine of 60, and then I'd multiply it by 12. All right? So if I wanted to, let's say let's do one more of these. So 2 cosine of pi plus I sine of pi times 3 cosine of negative pi halves plus I sine of negative pi halves. Okay. And so now I want to find the product there. So once again, I'm going to take and I'm going to multiply my two separate radiuses together. I'm going to add these together. So I'm going to add these angles together. Pi plus negative pi halves plus I sine of pi plus negative pi halves. All right, so this gives me 6. Cosine pi minus pi halves is pi halves. And so now I have here, I have 6 times the quantity cosine of pi halves plus I sine of pi halves. So that's the product. So let's look at division now. Let's get a couple of division problems up here and simplify those. So let's say I have 2 cosine of 3 pi halves plus I sine of 3 pi halves divided by 4 cosine of pi halves plus I sine of pi halves. Okay? So we're going to use our division formula here. So I'm going to have the ratio here. So I'm going to have 2 over 4. And now what I'm going to do is I'm going to subtract my angles. So I'm going to have cosine of 3 pi halves minus pi halves plus I sine of 3 pi halves minus pi halves. Okay. This gives me 1/2. 3 pi halves minus pi halves is 2 pi halves, which is just pi. So this gives me cosine of pi plus I sine of pi. And there's my division. Okay. It doesn't matter if I use radians or degrees, it's still going to give me the exact same style here. I'm just going to subtract them. Right. So we now have multiplication, we now have division, and so what we're going to look at now is we're going to look at de Moivre's theorem here, which deals with powers. Okay? Which is just, remember, powers are repeat multiplication, but this will give us a chance to kind of have not just looking at squares, but looking at higher powers. And so if I have here, if I have r cosine theta plus I sine of theta, and I'm going to take that whole thing and I'm going to raise it to the nth power. So now that I have it to the nth power, remember that we're expanding out. And so this n is actually going to come to that r. So this becomes r to the n. It almost looks like r to the r to the n. And then inside we have cosine of n theta plus I sine of n theta. And so we can take that power and we can multiply it in. Or it's not really multiplying it in. We end up bringing it inside to multiply the angle here. So if I have here, let's say I have 1 plus I to the 9th. Well, the problem with this is this isn't in complex form. So what we want to do is we want to put this in complex form. Now, this is an example that we did earlier in the lesson. So if you remember that, we found r was equal to the square root of 2. And we found theta was equal to, we'll use degrees, so 45 degrees. It would be the same as pi force in radians, but we'll leave it in degrees. So what I'm going to do is I'm going to convert this into trig form first. So I know square root of 2, and then this becomes cosine of 45 plus I sine of 45. And we're going to take that whole thing and raise it to the 9th power. Now looking back at de Moivre's theorem here, what I'm going to do is I'm going to take the square root of 2 and I'm going to raise it to the 9th power. Okay? So I'm going to take that square root of 2, raise it to the 9th power. I'm now going to multiply my angles. So this becomes cosine of 9 times 45 plus I sine of 9 times 45. Okay. So when we're looking at that, we want to make sure that we understand how to work powers. Square root of 2 to the 9th power, what's going to happen is remember it takes 2 square roots to bring out a whole. So there's 4 2's here. 4 2's, 2 times 2 times 2 times 2 is 16. So this is going to give me 16 square roots of 2. Okay? 9 times 45. This is 40. This is cosine of 405 plus I sine of 405. Now, what's the problem with 405? The problem with 405 is that it's actually more than one revolution around. Okay? So since it's more than one revolution around, we're going to actually subtract off 360, and we get cosine of 45 plus I sine of 45. Okay? This is the answer in trig form. Now, if I don't want trig form, if I want it back in standard form, I can convert it because I know what cosine of 45 is. I know what sine of 45 is. So this becomes 16 square roots of 2. Cosine of 45 is root 2 over 2 plus root 2 over 2i. So now what happens is when I bring in my 16 square roots of 2, this is going to cancel out and give me 8. Square root of 2 times square root of 2 is 2. 2 times 8 is 16. So this becomes 16 plus 69. The same factor will be here when we multiply. And so that's how we would take an item to a power. So what happens if I want to take a complex number to a root? Roots and powers are very, very similar. Right? So let's look at taking it to a root. So these are roots of complex numbers. Okay. So if I have here, if I have R, let's say I have R cosine of theta plus I sine of theta, and I want to take that all to the nth root. Okay, so that's 1 over n. What's going to happen is this becomes r to the 1/nth power. Right? Cosine of theta over n plus k times 360 over n plus I sine of theta over n plus k 360 over n. Oops. Because we have lots of occurrences. Remember, when we take the square root of a number like 4, I don't just get 2, I get plus or minus 2. So you have to take into account that plus side and that minus side. And that's what this k 360 over n is doing. It's taking into account that positive and that negative sign. Okay? So if I want to find, let's say I want to find the square root of 2 plus 2 root 3i. Okay, so I'm really looking at, this is what I'm trying to look at, is I'm trying to look at this to the half power. Okay, so this is kind of difficult because what that does is that puts it into a radical. So we need to find out r first. So we're going to go 2 squared plus 2 square roots of 3 squared. Okay, so that gives me 4 plus 12, which is 6 square root of 16, which is 4. So that's nice. That gives us a nice radius here. Remember, our theta is 2 square roots of 3, tangent inverse of 2 square roots of 3 over 2. So tangent inverse of root 3. So if you have your radian conversion chart, look at that first occurrence. Understand that this is in quadrant 1, so we want to be in quadrant 1. So tangent inverse of the square root of 3 gives me 60 degrees. Okay? So now I can put this into trig form. So now I have 4 times cosine of 60 plus I sine of 60 to the 1/2 power. So now I'm just going to follow my formula. So this becomes 4 to the half power, okay? Times the quantity, cosine. Now here's my angle, so I have 60 over 2, so n is 2 here, plus k times 360 over n, plus I sine of 60 over 2 plus k 360. This should be a 2 here also over 2. Okay. And so what's going to happen here is now we're going to look at kind of simplifying this. So the square root of 4 is 2. Okay. 60 divided by 2 is 30. plus k times 180 plus I sine of 30 plus k times 180, where k is a number of the natural number, or sorry, the whole numbers, not the natural. So 0, 1, 2, 3, so forth, so forth. If you remember, this is how we kind of found all those occurrences of the same value where we wanted, because remember, sine and cosine are periodic functions, and so this k ends up becoming just a whole number. So it's going to multiply this value here over and over again. Okay, I know it's a long section. We kind of went over things quickly, but there you have complex numbers and trig notation.